Bismillahirrahmanirrahim. Inshallah, today we're going to do synthetic substitution, and we're going to do polynomial division with this. Polynomial division. In other words, this is a shortcut to the long division using synthetic substitution. If you recall, we said before that there were three common uses of synthetic substitution. First is that if you're given a function like this, you can use synthetic substitution to find the value of the function for a given value of x like this, and then you can use synthetic substitution for that. And second is we can use synthetic substitution for doing long division problems. Okay, use long division problems. So this is a shortcut to long division. Right? And finally, we use synthetic substitution for finding zeros of a function. These are basically x-intercepts, and these are very important in being able to graph these polynomials. But this is a topic for the future. Today, inshallah, we're going to do long division using synthetic substitution. The term synthetic substitution itself is compared to direct substitution. Okay, that's when you actually put this value in the function to find the value of x. So synthetic substitution is called synthetic substitution compared to direct substitution, when you substitute the number in the function to find the value of the function. Okay, so these are three common uses of synthetic substitution, as we have talked about before. Today we're going to talk about long division. And inshallah, I'll tell you in the future why synthetic substitution works with some of these things. At least give you an idea of why this works. It seems like, quote, magical, right? So it's but there's a logic behind it, obviously. So let's do some problems. I'm going to do three problems, inshallah, for you as examples. So the first problem is this one: x squared minus 7x minus 11 divided by x minus 8. Okay. So if you were to do long division, you would write this over here: x squared minus 7x minus 11, and you write x, and you write x minus 8, right? Like this, and then you would go about doing the long division, right? But synthetic substitution, we don't do it like that. So we're going to do this long division using synthetic substitution. So what you do is, just like before for synthetic substitution, you copy down the coefficient and the constant term like this, making sure to fill any gaps that there might be if there are any terms missing. Okay, and then you make that line over there. This is how I do it. And then over here, you're substituting something. Well, what you're going to substitute is actually opposite of whatever this constant term. So we're going to do synthetic substitution, do long division only for binomial divisors like this. Okay, binomial divisors. So when you do that, what we put over here is actually the constant term over here. Okay, but the opposite of the constant term. So if it's negative 8, it's going to be 8 over here. If it was x plus 5, it would be negative 5 over there. Okay, so it's going to be the opposite of the constant term. Okay, and we're only going to do this using binomials, so it's going to be like this, baby type divisors. Okay, so what we're going to put here is 8. Okay, so now we're going to do syntax. Now when we do this, okay, when we do this, we're going to end up with some numbers over here, right? 3 numbers over there. And over here is going to be the remainder. So the remainder is going to be over here. And over here is going to be the result of the division, okay? So this is going to be the answer plus the remainder over there. Okay, so answer plus the remainder. Okay, what does that mean? Okay, I'll show you what that means. So let's do this. So doing the long division, remember, just bring the first term down like this, and then you multiply over here, and then you put it over there, right? 8 times 1 is 8, so that goes over here, and then you add, multiply, add, so you get 1 over there. 8 times 1 is 8. And then you add, and you get negative 3. Okay, and as I have said, okay, this is the remainder. Okay, and this is the answer. What does that mean? This means this is now you're dividing a second degree term by first degree term, so the answer is going to be x to the first something. Okay, it's going to be 1 less degree. So the answer is going to be x, 1x from here, plus 1, okay? And the remainder is minus 3 over x minus 8, like that, okay? So the answer to this, okay, is x plus 1 minus 3 over x minus 8, okay? So when you divide this out, if you were to do this long division, that's what you would get. And the coefficients over here, this one and this coefficient constant term, are the answers from the synthetic substitution. In this case, they happen to be 1, okay? So this is the answer to this polynomial division problem, okay? All right, so let's do another example. I have x squared plus 14x plus 38, and we're going to divide this by x plus 8 this time. So again, I copy down the coefficients and the constant term like this. Oh, sorry. Okay. So now in this case, we're dividing by x plus 8. So what's going to go over here is actually negative 8, the opposite of this. And then you do the long division like this. 1, negative 8 times 1 is negative 8. Add them, you get 6. Negative 8 times 6 is negative 48. And add them, you get negative 10. So the remainder, this is the remainder, okay? So that is the remainder. And this is like the answer for us. So the answer for this long division problem is going to be x, this 1x, plus 6. Okay, and that's the remainder, minus 10 over x plus 8. So this is the answer to this long division problem. And I hope you see this clearly, that it's much less painful than the long division. Much less cumbersome at least. Okay, I'd like to do one more problem, shall I? And here it is. So you have 2x cubed plus 7x squared minus 6x minus 8, okay? And we're going to divide this by this binomial x plus 4. Okay, so let's do this. So here I'm going to write the coefficients again. 2, 7, negative 6, negative 8. So there's no terms missing here, so that's good. But if there were missing, you would put those in there. And what goes over here? Goes there? Yes, very good. It's negative 4 that goes over there, okay? And then you do the long division, or synthetic substitution. Bring the 2 down, that's negative 8. That's negative 1. That's 4, that's negative 2, right? And that is 8. And you get 0. In this case, this is interesting because the remainder is 0. There's no remainder, right? So the remainder is 0. Okay, so the answer to this synthetic substitution is from here. Now this is third degree, so it's going to start out with one less degree. So 2x squared minus x minus 2. Okay, so this is 2x squared minus x minus 2. Okay, and this is the answer. And there's no remainder. Ta-da! So this is example where there is no remainder. So that's the answer. If you allow me, actually, I would like to do one more question here because I forgot. X cubed plus 5. Let's do this one. Divided by x plus 2. I wanted to do this example because there are terms missing. In this case, you would write down the coefficients, 1, but then there's x squared term is missing, x term is missing, and then the 5. See? It's like x cubed plus x squared plus x plus 5. And these two terms were missing because there were zeros there. Okay, so but you have to write those terms when you're doing the synthetic substitution. Okay, so let's do this then. And then you put negative 2 over here. Okay, and then you bring the 1 down. Okay, that's negative 2, and that's 4, right? And that's negative 8, and that's negative 3. Okay, so if you recall, this is the remainder. Okay, and the answer comes from here. It's going to be, when you divide this out, it's going to be one less term. It's going to be x squared minus 2x plus 4. And the remainder is minus 3 over x plus 2. I got it. You got to say. I mean, it's like almost a minute to do the whole problem. I mean, it can't get easier than that, right? So this is the answer to this long division problem. Okay. So alhamdulillah, I hope you appreciate that, and we shall build on this in the future next time. Until then, as-salatu was-salamu ala rasulillah. Assalamu alaikum.